Hello everyone. We are going to start a new chapter today. Probably relieved we can maybe stop talking about quadratics a little bit. We are actually going to start chapter 11, which is a different type of function that we're going to study called exponential functions. So just to start out, it's a little question. Would you rather have $1 million right now today just given to you, or would you rather have 1 cent doubled for 1 month? And it's an interesting question. You may have been posed this before, but turns out, and of course, if we had some more time in class, we would actually explore this a little bit more. But turns out it's much better to double a penny for 31 days. And when you see how fast this grows, here we're just start out with 1 penny. And by the end of the week, just by doubling it to 2 cents, 4, 8, 16, 32, okay, we're only at 64 cents. But at the end of the second week, we're at $81. And by day 31, we're over $10 million. So this is what exponential is like. It is like not something that's added each time. It's something that is multiplied. And so it grows much quicker. And if we were going to double this for more than 31 days, it's kind of tedious to just keep doubling. And so you might ask yourself, or I would, like, wow, what if we wanted to see what it was like for a year? Well, to have to do that 365 times rather than 31 would be probably quite tedious and annoying. So it turns out there is actually an easier way to do this. We can take this initial starting amount that we have right here, 1 cent, and we can multiply it by 2, and then multiply that by 2 and 2 and 2 and so on. And so that's what exponential functions are. So we're going to today identify and graph exponential functions using a t-table of values. So we'll go back to things that we've done before and to start out our work with exponential functions. So you can see that we have a worksheet today that will be in the assignments folder. And of course, you can follow along with this blank lesson and work through the examples with me. You'll find that in the blank lessons folder on Schoology. So exponential functions, they're in the form of y equals a times b raised to the x power. Okay, well, this is a pretty classic exponential function example. This example right here shows the insect population over time. And so if you look at 0 days right here, the insect population, there are just 2 insects. After 1 day, there are 6 insects. After 2 days, there are 6 times 3, 18 insects. After 3 days, 54. So what's happening is this population is tripling. And if you look at what that looks like on a graph here, okay, it starts out here and then it goes grows quite quickly. So this function rule, okay, that describes the pattern above is f of x equals 2 times 3 to the x power. And this type of function where the x is the exponent or the independent variable appears in an exponent is called an exponential function. So notice a couple things about this example also. Okay, notice that the 2 right here, that is our starting population, and that is that number right there. Also notice that when it's tripling here, this times 3 part is what we're raising to that x power. And what the x stands for is the number of days. So we could calculate, this is only after 3 days. If we actually wanted to calculate the insect population after 10 days, all we would have to do is take that original equation and substitute in a 10 for the x. And if I go ahead and do that, 2 times 3 raised to the 10th power, that gives up an insect population of 118,098. So wow, if that was an annoying bug, after 10 days, you'd have a lot of them. So this is the general equation, and this is what you're going to want to put in your notes. Today, you're not going to have to worry about what A and B and X mean, but eventually you're going to find out or figure out that A really stands for your initial starting amount. Okay, so keep that in mind as you work through these examples and you start looking through some of these things. To start noticing things, I think that helps you understand the equations better. So A is the initial amount, and B is sort of what we call the multiplier, or how fast it's growing. All right, and you might want to stop and actually just write that down. But today we're just going to have to plug things in. So if we compare these two, they look very similar. This is 2 times x. And this one, the green one, is 2 raised to the x. And on your calculator, you'll have to calculate using that arrow key, which is, I'll show you that in a minute. So what do you think these graphs will look like? Well, hopefully some of you might remember back that this is actually a linear function. But what does this look like? So if we were to calculate and wanted to graph these, all we would do is we would take 2 and multiply, put in the x value, and that gives us -4, okay? On the other side, for the green here, what we would do is we would take 2 and we'd raise it to the -2 power. And when we do that, that gives us 0.25. Okay, so rather than me just keep calculating all of these, let's just fill the rest in, okay? And I said 0.25, but that's the same as 1/4. And here's what the graphs look like. So you can see the blue graph, f of x equals 2x, is a line. It's linear. And remember, it comes from y equals mx plus b. That was one of the first things we studied this year with functions. And the green one is our exponential function. And that's what we're going to study. And notice, it's not a straight line. But it's also not a parabola like we've been studying, because it doesn't come back up. What happens with these exponential functions is it gets closer and closer and closer and closer, okay, to the x-axis, but it never actually crosses it. So, how do we graph an exponential function? Well, that's what we're going to work on right now. So to graph an exponential function, what you do is you make a t-table of values. Make sure you use both positive and negative values for x. Plug them in, find the y values or the f of x values, however you want to, that's the y value or your f of x, and make sure you include 0. And so a good place to start is just our old basic -2, -1, 0, 1, and 2. So now what I do is I take my x value right here, -2, and I have to plug it in for the x. So that's going to look like 0.5 times 3, and then you're going to use the arrow key. Okay, so your arrow key, you're going to have to use the arrow key. And the arrow key is that little, I don't know, I think sometimes they call it a caret key, an arrow key. So that's what you would type in there. And when you do that, for this first one, we're going to round these because they're going to be some nasty decimals, but we'll round to the nearest hundredth because we're not going to be able to graph anything other than that. It'll be too difficult to graph. So again, if I put this next one in, what I would actually do is I would take 0.5, 3, then I'd use that arrow key right there and raise it to the -1 power. So that's how that looks, and that gives me 0.17. Keep going, and I would try these. Maybe pause the video right now, see if you can calculate these on your own on your calculator. Then hit start again, or play, and then you will get these values. Now, sometimes like in the past, you can add other positive or negative values. So now we graph it. Well, yeah, it is hard to graph -2.06. Well, here's -2, 0. Well, it's just barely going to be above that. So I'm just going to graph as best I can, just barely above that line right there. Then I'm going to graph -1, just 0.17. Again, that's not even up to 0.5 yet, so that's like barely noticeably different. Then I have 0 is 0.5, so that's a little bit easier to graph right in the middle there. Then I have 1 is 1.5, that's a little bit easier to graph. 2, 4.5. And I mean, I could stop there, but I'll just go ahead and plot 3, 13.5. I believe is right there if I did my counting right. So your exponential functions, you connect. Remember, we chose the x values, so we connect the points. And again, we do not cross that line. It gets closer and closer, but never crosses. So there's your exponential function. All right, let's try just a couple more, and then I'll have you try some on the homework. And don't forget to check your answers on the key as you go along so you're not making mistakes. So make a graph, make a table and graph these two exponentials. All right, so let's start with this one. Draw my t-table. I try -2, -1, 0, 1, and 2. Notice I left a little space in case I do need to add -3. I don't know sometimes at the time if I'm going to be able to see that curve. That's what you're looking for. So I'm going to take 4 times and then 0.6, and I'm going to use that little arrow key again to the -2 power. And so when I type all that in my calculator, that gives me 11.1. Now I'm going to do it for the next value, and that gives me 6.6. Again, you might want to pause the video here, try some of these on your own, and make sure you're doing it right. I'm not going to take the time on the video to go through each and every one. I'm going to add a 3 as well. So now we'll plot those points once you get the values. Again, these can be difficult to plot, but do your best. So now I have -2, 11.14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11 is above this. Okay, so there's that value, -1, 6.6. So just a little over 6.5. And 0, 4, that's a nice one to graph finally. Then I get 1, 2.4, just a little under 0.5. 2 is 1.44. And 3 is 0.87, so just a little under 1. So you might want to, add other values, but it's just going to get closer and closer and closer to that x-axis. Notice some are curving the other direction. Start to notice why you think that's happening. What part of the equation is different that's making that happen? Don't forget arrows on each end, but notice this one was going sort of up, okay? And what's making that do that is this number inside here, okay? Compare that to this number inside here, which is less than 1. That's making it sort of go down because it's actually not being multiplied by a number, it's being divided. Okay, so let's do one more here. And then what I'll do is I will work out 2 more examples for your notes. If you want to try the next 2 in these blank lessons, I don't think I'll include them in the video here, just for time's sake. So as we plot this one, we're going to take 1/2 and raise it to the power. I would just use 0.5, but you could certainly type in 1/2 on your calculator. I just think 0.5 is going to be easier. And so when we plug in 0.5 and raise it to the -2 power, we get 4. And then again, we get 2. I would pause, give this a try on your own, pause the video, then see if you're getting them right. Because most of this is calculator work. So if you're not getting them correct, it's because you're not using your calculator the right way. So make sure you get that down. So here I'm graphing the next one. So both of these are sort of going down, going kind of curving in the same direction. And again, notice that this is a number less than 1. All right, well, hope this is making sense. This is pretty easy as far as just plugging in numbers, but make sure you're able to do it correctly on your calculator. Have a great day, everyone.